Where do I call the batch normalization function in Keras? If I want to use the batch normalization function in Keras, then do I need to call it once only at the beginning? I read this documentation for it, this URL. I don't see where I'm supposed to call it. Below is my code attempting to use it. I ask because if I run the code with the second line including the batch normalization and if I run the code without the second line I get similar outputs. So either I'm not calling the function in the right place, or I guess it doesn't make that much of a difference.
As Pavel said, batch normalization is just another layer, so you can use it as such to create your desired network architecture. The general use case is to use BM between the linear and non-linear layers in your network, because it normalizes the input to your activation function, so that you're centered in the linear section of the activation function, such as sigmoid. There's a small discussion of it here. In your case above, this might look like
It's almost become a trend now to have a conv2d followed by a relu followed by a batch normalization layer. So I made up a small function to call all of them at once. Makes the model definition look a whole lot cleaner and easier to read.
Keras now supports the use_bias equals false option, so we can save some computation by writing like or.
Batch normalization works best after the activation function, and here is why. It was developed to prevent internal covariate shift. Internal covariate shift occurs when the distribution of the activations of a layer shifts significantly throughout training. Batch normalization is used so that the distribution of the inputs, and these inputs are literally the result of an activation function, to a specific layer doesn't change over time due to parameter updates from each batch, or at least, allows it to change in an advantageous way. It uses batch statistics to do the normalizing, and then uses the batch normalization parameters, gamma and beta in the original paper, to make sure that the transformation inserted in the network can represent the identity transform, quote from original paper. But the point is that we are trying to normalize the inputs to a layer, so it should always go immediately before the next layer in the network. Whether or not that's after an activation function is dependent on the architecture in question.
If you want to support the channel, please consider liking and subscribing.